The problem is calculate the moment of inertia for a triangle of height 100 mm about an axis passing through the vertex and parallel to the base if moment of inertia about base is 10 raised to 4 mm raised to 4. Now first of all we will draw a diagram here. See this diagram here. In this diagram there is a triangle ABC where this AB is the base of the triangle and C is the vertex. This C is the vertex of this triangle, and we have to calculate the moment of inertia for a triangle about an axis which is passing through the vertex and parallel to the base. So here this PQ axis is passing through the vertex here and parallel to this base AB here. So we have to find out the moment of inertia of this axis PQ. So in given we will write IPQ is the moment of inertia of the axis which is passing through the vertex and parallel to the base, and that we have to find out here. Next, in given we will write the height of triangle, and this height of triangle is 100 mm. Then the moment of inertia about base is given here, and that base is AB here. So moment of inertia of base AB, that is IAB, is equal to 10 raised to 4 mm raised to 4, that is given in this question here. So now next we will check the units here. So the unit of moment of inertia is mm raised to 4 and the unit of height is mm here. So we will do not convert any unit. Now we will find out this moment of inertia about an axis which is passing through the vertex and parallel to the base, that is IPQ. The formula to find out the moment of inertia about an axis which is passing through the vertex and parallel to the base, that is IPQ is equal to BH cube by 4. So B is what it is, the base of the triangle here, and H is the height of triangle. So we are having height of triangle, but we don't know the base of the triangle, that is B. So as we are knowing the moment of inertia of a triangle about base IAB, so that IAB is equal to BH cube by 12. This is the formula to find out the moment of inertia of a triangle about its base. So here we are having the value of IAB, that is 10 raised to 4, is equal to B into what is H. H is 100, so here it will be 100 cube divided by 12. Then we can write here B is equal to 10 raised to 4 into 12. This 12 we are cross multiplying here, divide by 100 cube. And if we calculate this 10 raised to 4 into 12 divided by 100 cube, then we will get the value of B as 0.12 and the unit of base will be mm here. So here B is equal to 0.12 mm. Now putting the value of B in the formula of IPQ, so we can write here IPQ is equal to what is B, 0.12 into what is value of H, that is 100 cube here, divided by 4. And if we calculate this 0.12 into 100 cube divided by 4, then we will get the answer of IPQ is equal to 3 into 10 raised to 4, unit will be mm raised to 4, because IPQ is what? It is the moment of inertia here. So IPQ is equal to 3 into 10 raised to 4 mm raised to 4, and this is the moment of inertia for a triangle about an axis which is passing through the vertex and parallel to the base. So this is the solution of this problem. The question is, find the moment of inertia of a square section about its diagonal resting on one of its corner having diagonal 400 mm in length. So first of all, we will draw the diagram. See this diagram here, it shows the square section, that is ACBD here, in which AB and CD, these are the two diagonals, and these two diagonals having length 400 mm. So CD is equal to 400 mm and AB is equal to 400 mm, and these two diagonals, they are bisecting each other at this point here. So as these two diagonals, they are bisecting each other at this point O here, so the length of AO, BO, CO and DO will be same, because they will equally bisect each other here. So the length of AO, BO, CO and DO is 200 mm here, is 200 mm, and this square section is resting on one of its corner, and that corner is C here. This square section is resting on one of its corner here, and what we have to find out? We have to find out the moment of inertia of a square section about its diagonal. So here there are two diagonals AB and CD, so we will consider here the diagonal AB, and we have to find out the moment of inertia of a square section about its diagonal AB. So we do not have the formula to find out the moment of inertia of a square section about its diagonal. So we will divide this square section here in two triangles, and those two triangles are triangle ABD and triangle ABC, and these two triangles, triangle ABD and triangle ABC, they having a common base, and that common base is AB. So AB is the common base of these two triangles. So we can write here the base length of these two triangles, that is B is equal to AB is equal to 400 mm, and the height of these two triangles, that is H is equal to DO is equal to CO is equal to 200 mm. So this will be the height of these two triangles here. DO is the height of triangle ABD and CO is the height of triangle ABC, and AB is what? It is a common base of these two triangles. So we are taking small b as the base length of these two triangles, and that is equal to 400 mm, and H is the height of these two triangles, that is equal to DO is equal to CO is equal to 200 mm. As AB acts as a common base of these two triangles, triangle ABD and triangle ABC, so we will find out the moment of inertia of the triangle ABD about its base, that is IAB is equal to BH cube divided by 12, and this moment of inertia IAB will be same for this triangle ABC also. So we will multiply this by 2 here, then we will get the moment of inertia about the diagonal AB of the square section. Diagonal AB of this square section. Now if we put the values of B and H here, then we can write IAB is equal to what is B, 400, into what is H, 200 cube here, divide by 12 into 2, and if we calculate this, then we will get the answer of IAB as 533.33 into 10 raised to 6, and the unit of moment of inertia will be mm raised to 4. Again, see here, as AB is a common base for these two triangles ABD and ABC, so we will take the formula to find out the moment of inertia of a triangle about its base, and that base is AB here, and we are considering the triangle ABD here, and that should be BH cube by 12, but the triangle ABC is having same base and same height, so the moment of inertia of the triangle ABC about its base AB will also same here, so we will multiply this by 2, and after multiplying this by 2 here, then we will get the moment of inertia of this whole square section about this diagonal AB here. Now after that we are putting the value of B and H here in this formula. So IAB is equal to 400 into 200 cube divided by 12 into 2 here, and after calculating this we will get the answer of IAB as 533.33 into 10 raised to 6, and the unit of moment of inertia is mm raised to 4 here. So this is the total solution of this problem. The question is, a circular disc has moment of inertia about its any1 tangent is 6.283 into 10 raised to 5 mm raised to 4. Calculate the diameter of disc. So first of all we will draw the diagram. See this diagram here. In this diagram, this is a circular disc here. This is a circular disc which having diameter capital D here, and this diameter we have to calculate. So first of all we will write given here. In given we have to find out the diameter D. Next is a circular disc having a moment of inertia about its any1 tangent, and that any1 tangent is AB here. We are considering that any1 tangent is AB, and the moment of inertia of the tangent AB, that is given here, and that moment of inertia of tangent AB is 6.283 into 10 raised to 5 mm raised to 4. So this is the moment of inertia of a circular disc about its any1 tangent. Now see here, we have to find out diameter D, and we are given the moment of inertia of a circular disc about its any1 tangent. So we are not having any formula to find out this moment of inertia of a circular disc about its tangent. So we will use here a parallel axis theorem. we will use here a parallel axis theorem, and this parallel axis theorem we are applying to this axis AB, that is the tangent AB. So we can write here the moment of inertia of axis AB, that is tangent AB, is equal to the moment of inertia about an axis which is parallel to this AB and passing through this centroid of this circular disc. So see here, this is the centroid G of this circular disc, and this x-axis is passing through the centroid of this circular disc and it is parallel to the AB. So we will write here Ixx plus area and the perpendicular distance between the two axes, and that perpendicular distance is h here, and we will take the square of the h. So IAB is equal to Ixx plus AH square, and this is the formula for the moment of inertia of axis AB, that is tangent of this circular disc, by using the parallel axis theorem, and that is IAB is equal to Ixx plus AH square. Now we have to find out diameter D here. So see here, we are having a value of IAB. Now we will take the formula for Ixx, that is the moment of inertia of a circle about the centroidal x-axis, and that formula is pi by 64 d raised to 4. This is the formula to find out the moment of inertia of a circle about centroidal x-axis. Next, we will write the formula for area here, and the area of this circle, that should be equal to pi by 4 d square, and the height h, that is the perpendicular distance between these two axes, and this h is equal to, here it should be diameter divided by 2. So we will write here d by 2, and if we put these equations Ixx, A and H in this IAB is equal to Ixx plus AH square, then we can write here IAB is equal to pi by 64 d raised to 4 plus pi by 4 d square into d by 2 whole bracket square. Then we can write here IAB is equal to pi by 64 d raised to 4 plus pi by 4 d square into, this will be d square by 4 here. Then we can write here IAB is equal to pi by 64 d raised to 4 plus pi divided by 4 into 4 16, and this d square into d square d raised to 4 here. Next we can write here IAB is equal to, if we take pi into d raised to 4 common here, then we can write in bracket it will be 1 by 64 plus 1 by 16. If we calculate this 1 by 64 plus 1 by 16, then we can write here IAB is equal to pi into d raised to 4 in bracket. The answer of 1 by 64 plus 1 by 16 is 0.0781, and after that if we calculate this pi into 0.0781, then we can write IAB is equal to d raised to 4 into pi into 0.0781 is equal to 0.0781 245. Now we are putting the value of IAB here. So IAB is what? It is 6.283 into 10 raised to 5 is equal to D raised to 4 into 0.245. Now we can write here D raised to 4 is equal to 6.283 into 10 raised to 5 divided by 0.245, and if we calculate this, then we will get the answer of D raised to 4 as 2.56 into 10 raised to 6. 2.56 into 10 raised to 6, and if we take the fourth root of this 2.56 into 10 raised to 6, then we will get the answer of D as 40, and the unit is mm here. So the answer of diameter of a disc, that is capital D, is equal to 40 mm, and this is the solution of this problem. The question is, a hollow cast iron pipe, that is CI pipe, with external diameter 100 mm and thickness of metal 10 mm is used as a strut. Calculate the moment of inertia and radius of gyration about its diameter. First of all, see here, a hollow cast iron pipe is used as a strut. Strut means the hollow cast iron pipe is used as an inclined column. That is called a strut, or used as an inclined structural member. That is called strut. So see here, a hollow cast iron pipe having external diameter 100 mm and thickness of metal 10 mm. We have to find out moment of inertia and radius of gyration about its diameter. So first of all, we will draw the diagram. See this figure here. This figure shows a hollow cast iron pipe. See here, this is a hollow cast iron pipe here, which having external diameter 100 mm. So external diameter is capital D here, that is 100 mm, and thickness of metal 10 mm. So this is the thickness of metal, that is T here. See here, this thickness is 10 mm. So this is also thickness here 10 mm. Then there will be an internal diameter of this hollow cast iron pipe, and this internal diameter is denoted as small d here. So first of all, we will write here given. In given, first we will write the external diameter, that is 100 mm, then the thickness of metal, that is 10 mm. Now we can write here the internal diameter small d should be equal to the external diameter capital D minus of 2t. We have to take both side thickness here. So capital D minus 2t is equal to small d. So internal diameter small d is equal to 100 minus 2 into 10. Then we can write the internal diameter is 80 mm. What we have to calculate? We have to calculate the moment of inertia and radius of gyration about its diameter. So in case of this hollow circular pipe, we will consider the two diameters here along x-axis and along y-axis. Why? Because we have the formula for moment of inertia and radius of gyration in case of this hollow circular section for both x-axis and y-axis. So here we will write, first we will find out the moment of inertia along x-axis, that is I-axis, and moment of inertia along y-axis, that is IYY. Then we will find out the radius of gyration along x-axis and the radius of gyration along y-axis. So these are the moment of inertia and radius of gyrations. We have to find out about the diameter of this hollow circular pipe. For a hollow circular section, the moment of inertia along x-axis and moment of inertia along y-axis having same formula, and that should be pi by 64 in bracket capital D raised to 4 minus small d raised to 4. So this is the formula to find out the moment of inertia along x-axis and along y-axis for a hollow circular section, and this formula for x-axis and y-axis is same. So if we put values here, then we can write pi by 64. What is capital D? It is 100. It will be 100 raised to 4 minus small d is 80. So here it is 80 raised to 4 bracket complete. If we calculate this pi by 64 in bracket 100 raised to 4 minus 80 raised to 4, then we will get the answer for a moment of inertia, that is Ixx and Iyy, as 2.898 into 10 raised to 6, and the unit will be mm raised to 4 because the diameters and thickness having unit of mm. So here the moment of inertia of this hollow circular cast iron pipe about its diameter along x-axis and along y-axis, Ixx is equal to Iyy is equal to 2.898 into 10 raised to 6 mm raised to 4. Next we will calculate the radius of gyration. So see here, the radius of gyration along x-axis, that should be equal to kxx, and that is equal to the square root of Ixx divided by a. So we are having the value of moment of inertia along x-axis, that is Ixx, but we have to find out this area. Now this is a hollow circular cast iron pipe, so area of this hollow circular section, that should be equal to pi by 4 in bracket capital D square minus small d square. Now if we put the values here, then we can write here it is pi by 4. What is capital D? 100 square minus small d is 80 square. And if we calculate this pi by 4 in bracket 100 square minus 80 square, then we will write the answer for area of this hollow circular section as 2.827 into 10 raised to 3, and the unit for area is mm square. Now if we put the values of Ixx and area A in this formula of radius of gyration, then we can write kxx is equal to square root of, what is Ixx? It is 2.898 into 10 raised to 6 divided by, what is area? 2.827 into 10 raised to 3. And if we calculate this square root of 2.898 into 10 raised to 6 divided by 2.827 into 10 raised to 3, then we will get the answer for radius of gyration kxx, that is equal to 32.017, and the unit for this radius of gyration is mm here. And this radius of gyration along y-axis will be same. Why? Because the value of area and the value of moment of inertia along y-axis is same. Because of that, kxx is equal to kyy. So these are the answers of moment of inertia and radius of gyration about the diameter of this hollow cast iron pipe. So this is the solution of this problem. The question is, calculate the moment of inertia of a hollow rectangle about an axis passing through the bottom side. The outer dimensions are 300 mm into 450 mm and the inner dimensions are 200 mm into 350 mm. So first of all, we will draw a diagram here. See this diagram here. It shows this hollow rectangular section here. See here, this is hollow rectangular section in which this is centroidal x-axis and this is centroidal y-axis of this hollow rectangular section. What we have to calculate? We have to calculate the moment of inertia of a hollow rectangle about an axis passing through the bottom side. So see here, this is the bottom side here of this hollow rectangular section, and we have to find out the moment of inertia about an axis passing through the bottom side. So passing through this bottom side, the axis is AB here. So we will write in Q1, we have to find out the moment of inertia of a hollow rectangle about its axis passing through bottom side. So we have to find out IAB here. Next, the outer dimensions of this hollow rectangle is given, that is 300 mm into 450 mm. See here, base is 300 mm, depth is 450 mm. These are outer dimensions. So we will write here capital B is equal to 300 mm and capital D is equal to 450 mm. Next, inner dimensions are given, and inner dimensions, the base is 200 mm and the depth is 350 mm. So we will write here inner dimensions. First is base as small b, and that is equal to 200 mm, and the depth, that is small d here, it should be 350 mm. Next, we will check the units here. All the units are in mm, so we will do not convert any unit here. Next, we will write a formula to calculate this moment of inertia about an axis passing through bottom side, that is AB axis here. So we do not have the formula for this, so we will use here a parallel axis theorem. So if we use a parallel axis theorem here, then we can write here IAB is equal to, for this AB axis, the parallel centroidal axis is x here. So we will write here moment of inertia of a centroidal axis which is parallel to the AB, that is Ixx, plus area into h square. So this h is the perpendicular distance between AB and the centroidal x-axis. See here, this is x-axis, so this h is the perpendicular distance between this x and AB, x-axis and AB axis. So we will write here h square. Now we will first calculate here the moment of inertia of this hollow rectangular section along its centroidal x-axis, that is Ixx is equal to capital B capital D cube minus small b small d cube divided by 12. This is the formula to find out the moment of inertia of a hollow rectangular section along its centroidal x-axis. Now we will put values here of capital B, capital D, small b and small d. Then we can write Ixx is equal to, what is capital B? It is 300 into 450 cube minus small b 200 into small d 350 cube here divide by 12, and if we calculate this, then we can write Ixx is equal to 1.56 into 10 raised to 9, and the unit will be mm raised to 4. So this is moment of inertia of a hollow rectangular section along its centroidal x-axis, that is Ixx is equal to 1.56 into 10 raised to 9 mm raised to 4. Next we will calculate the area here, and area A for this hollow rectangular section, that should be equal to the area of bigger rectangle, that is capital B into capital D, minus area of smaller rectangle, that is small b into small d. If we put values of capital B, capital D, small b and small d here, then we can write capital B is 300 into capital D 450 minus small b 200 into small d 350, and if we calculate this 300 into 450 minus 200 into 350, then we can write the answer for area of this hollow rectangular section is 65,000, and the unit will be mm square here. So area of this hollow rectangular section is 65,000 mm square. Next, what we have to find out, we have to calculate the height h, and this is the perpendicular distance between this x-axis and AB axis, and this height here, it should be equal to the capital D by 2. See here, this height h is equal to capital D by 2. So capital D is 450 divided by 2. So the height, that is the perpendicular distance between the x-axis and AB axis, is 225 mm. Now if we put the values of Ixx, then value of area A, then value of this height h in this formula of AB is equal to Ixx plus AH square, then we can write IAB is equal to, what is Ixx? It is 1.56 into 10 raised to 9 plus, what is area? It is 65,000 into, what is h? It is 225, and we have to take square of that h. And if we calculate this 1.56 into 10 raised to 9 plus 65,000 into 225 square, then we will get the answer of moment of inertia along this AB axis as IAB is equal to 4.85 into 10 raised to 9, and the unit will be mm raised to 4. So this is the moment of inertia of a hollow rectangular section about an axis passing through bottom side, and that axis is AB here. So IAB is equal to 4.85 into 10 raised to 9 and the unit will be mm raised to 4. So this is the solution of this problem.